Hi guys, so today I will be showing you how to draw an orthographic view, specifically the isometric projection of a cylinder. So the plan of a cylinder is a circle and the elevation of a cylinder is a rectangle. If you saw my previous video, you will know how to do the setup, which is pretty easy, and I have some of it done already here. As you can tell, I have the border done here and I have the text box all nice and done for the title and your name. So first of all, I drew the axis, which to draw the axis, I used this ruler and I just brought a line down, which I've marked with a blue marker so it is easier to see on camera. I drew this line. It doesn't matter what length at all, just as long as it's centered. So I drew this line. Then, using my set square, I put it into the 30-60 form. So if you're using traditional set squares, it's this one. So basically, we have a 90-degree angle, a 30-degree angle, and a 60-degree angle. And so my adjustable set square is set to the 30-60. And using the 30 side, I drew this line, and I drew that line, as you can see. So again, doesn't matter what measurements these are, but that gave us the axis, which is the X, Y, and Z. Then I started drawing the construction of the axometric plane, which is a triangle. So I basically just drew a line here. Doesn't matter what length, where, as long as it's not too big or too small. This is like the perfect size. It's if it's too small, it's too hard to work with. This is the perfect size. And then using the 60 side of my set square, which is this side, I drew this line from where the line ended on the blue line going up, and then the other side, I joined the two together and it formed a triangle. If yours don't perfectly make a triangle, then you went somewhere wrong and you have to restart over again. If you measure using a protractor, you can see that between these blue lines, from here to here is 120 degrees. From this blue line to this blue line is 120 degrees, and the same for here. They're all equally 120 degrees. And using your 30 side, if you bring this line out further, you can see that when you join it to this line, it is perpendicular at a 90-degree angle, and that's how it should be. If it's not perpendicular, then again, you went somewhere wrong. So that is how much we have so far. If you need time to catch up, pause this video and do so. I will be continuing on though. And so now I'm going to do this third step, which is rotating the triangular vertical plane to see the true shape. So basically, using the 30 side, I will be bringing out this, the top of the triangle, and the bottom of the triangle. And as you can see, these two lines are perpendicular to this line, and that's how it should be. Then using the 60 side, I will draw a line perpendicular to, parallel to this, like so. Now I will quickly, using a pink marker, go over these two lines just so you can see it better in the video. Now we have marked these. These are parallel to each other and to this line. Now we have to bisect this line. That bisecting means basically dividing it in two or finding where the half is. Yes, you can do it with a ruler, but an even more precise and the correct technical way to do this is using a compass. So you put your needle on one end of the line and you make it bigger than approximately bigger than a half, and you draw an arc. Then you put the needle on the other corner and you draw an arc again. Now, where these two arcs meet, you join together to create a line. Now, where this line meets that line, this point is the middle of the line. Now that we have found the middle, using our compass, we will put the needle in the middle and we will draw a semicircle for that line, like so. Now I will go over the semicircle quickly in pink just so you can see it better in the video. There we go. There is the semicircle. Now, using the 30 side, we bring this line that we have here further out until it reaches the semicircle. Then we get this point, and that point we join to the end of the semicircle here, like that, and here, like so. And now I'll quickly go over these lines with a blue marker so it's more visible in the video. There we go. We have these two blue lines. This is where we will be drawing our elevation for the cylinder. For now, we will leave that, and we have to do the exact same process now over here at the bottom. So I'll just quickly do this fast. Bring this line down, bring this down, join these together on the middle. And there we go. I am quickly going to go over all of these lines with my colored pens just so it's more visible and clear for you guys. There we go. We now have the setup done for the drawing, as you can see. So basically now, to draw the cylinder, I think first off we will do the elevation because it's the easiest. And the elevation is basically if you're looking at it straight forward. So if you're looking at a cylinder straight forward, it will look like a rectangle. So if the radius of the cylinder is 30 millimeters, then the diameter is going to be 60 millimeters. So we measure here 60, and it's okay if it goes beyond the blue line. That's fine. We're just using the blue line as a guideline to where to draw. Now, that is 60. And the cylinder's height is 100 millimeters, so 10 centimeters. I'm going to use a different ruler just so it's easier for me to measure. And there we have 10. So I'll just draw this, bring this up. There we go. Now, using sliding set squares, like I showed in the previous video, if you are using the traditional set squares, you can use, if you're using the traditional set squares, you line up one set square with the line, like here, and then you put the other underneath, and you slide it up until you reach the measurement where you need it to, and you draw it. So this line is now parallel to this. If you are using the adjustable set square, then you take your set square, you line it up with this. I'll line it up like that. And we put the ruler here, line this up, and now we slide it to where the mark is, and we draw it up. So this is now parallel to that, and there you go. That is our rectangle, and that is the elevation done. Now we have to do the plan, which is going to be a circle for a cylinder. So if the radius is 30 millimeters, we have to find the center of the circle to draw it. So we measure 30 millimeters here, and we adjust the set square to be 45 degrees if it's adjustable. Or if you're using the traditional ones, then you just take this set square and put it like that. So basically, where you made the measurement, I'm just going to bring this out like this. Then on this side, I'm going to measure 30 millimeters again, so 3 centimeters. And I am going to bring this line out as well. Now where these two lines meet is the center point of the circle. So now, taking my compass, I can take it here, put it in the center, and now I can draw a circle. There we have it. And there's a circle. That is the plan of the cylinder. So now we have the elevation and plan done. Now it's time to draw the 3D cylinder. But because it is a circle, it might be a little bit more harder than when we did a cuboid. So let's first off begin by drawing the circle at the bottom, at the base. So to draw the circle, we first have to divide the circle into sections. So I'm going to, there's already a line here, so I'm just going to bring it out further. There is already a line here. I'll bring that out further. I'll do a horizontal line. And I'll do a vertical line. So now the circle is divided into 1, 2, 3, 4, 5, 6, 7, 8 sections. So now that we have the 8 sections, we know that this here is going to be here. This is going to be the middle. So we find the middle of 60, that's 30. So let's start labeling this, okay? So let's say this is A, B, C, D, E, F, G, and H. So now we know that A is going to be here. We know that E is going to be here. G and C will be here. C and G. And then we need to find out where B and D is going to be on here at the base. So what we simply do is from the point B on the circle, we just bring it up to this line using the 45. And do you see where it hits here on the blue line? We measure that. That is 8 millimeters. So we measure 8 millimeters up here. And boom, we have the point where B and H are going to be. Because B and H, if you brought this line down, they're on the same point. So this is going to be B and H. And you could do the same to D, but I'm just going to assume that it's going to be the same, and it's going to be 8 millimeters. So it's going to be here. So that's going to be D and F. D and F. There we go. So now, like we did with the square in the last drawing, we have to just bring them all and connect them. So I'm going to set my set square to, again, 3060 line. And if you're using the traditional ones, you can just use this one. So I'm going to, parallel to this line, I'm going to bring B and H down. And now connect B to the line. And there you go. Where they connect, we got B. Now, we have A going here. So we're going to bring A up here. There where they meet is A. Now, we are going to bring up C and bring up C here. They both meet here. So there we go, C. We bring up D, wherever D hits the line. There we go. That is point D. Now we bring up E. Wherever E hits the line over here. That is point E. Bringing this out till it hits this line, which is for F. Bring this line out for G. Bring that up. That is G. And bring this up for H. Meets there. And that is H. Now, freehand, connect all the dots to draw an oval. So I'm just gonna freehand this. And yes, sometimes in technical drawing, you do have to freehand stuff like this when you have points to do it. There we go. And there's our oval. Now, we are going to bring H up and D up. And now we have to do the same for the top. So let's use numbers now to measure this. So let's say 1, 2, 3, 4, 5, 6, 7, and 8. So we know that 1 is going to be over here. 5 is going to be here. We have to find the middle of that line to get, so the middle is 30. So that's going to be 3 and 7. From previously, we know that if we go in 8 millimeters, that is going to be 2 and 8. If we go in 8 millimeters here as well, I'm just going to use a different ruler. If we go in 8 millimeters, that is going to be 4 and 6. There we go. So now that we've marked those, we do the exact same thing. We can start with 1. We bring 1 up and 1 is up here. So we bring that up. Boom, it hits the line here. That is our 1. Okay, number 2 is here. So we bring that line up and bring this across, and 2 is over here. Mark that as number 2. Now number 3, we bring this up, bring this out where the 2 meet. That's our number 3. Now bring 4 up and bring 4 across here where they meet. That's 4. Number 5, bring this out where they meet. That's number 5. 6, bring this out further where they meet. That's 6. 7, that's already brought up, so just bring this further. They meet over here, so that's 7. And then 8, lastly, is we bring this out further. And where the 2 meet, that is our point 8. So now we again have to freehand an ellipse, which is basically just a circle, but because it is 3D, it doesn't look symmetrical. It looks like an oval, simply put. So and there you have it. If you cannot see, we have the cylinder here drawn. So now I am going to take a black fine liner, 0.5. It doesn't matter. It can be thicker, thinner. I'm just gonna go over it. You don't even have to go over a black fine liner. I just like to because it makes my final product stand out more. And plus, I want you guys to be able to see this in the video. So first of all, I'm gonna do the top because obviously we can see the top. So I'm just gonna go over all the lines. There we go. And there is the top of the cylinder. Now, the furthest point is 8 that we can see. So we bring this down to H and 4 down to D. And there we go. Now, the bottom one, we only draw from H to D because that's the only part we can see. If it's a solid, the only part we can see of that, if it was standing in front of us, would be that much. Now, we know that there's a line here that it continues, but we can't physically see it. It is behind us. So, like we did with the cuboid, we are just going to do dashed lines like this. So, people know that there is a line there, but we just cannot see it as it is behind us. And there we have it. That is a perfectly done cylinder drawn. There we go. I hope you guys enjoyed this, and I hope you liked watching the video and learned something new. Make sure to like, comment, and subscribe. Bye!